Since talking about forces, we said that one of the things that a force can do is make an object move. We need to talk a little bit about the motion of an object. And some of these things are very, how shall I say, common sense, things that you're already very familiar with. For instance, if we want to talk about the speed, how fast is something going, we talk about, let's take our cars, for instance. As we're driving down the road, here's my version of a car. As we're driving down the road, oh, better put some wheels on there. Then we might say that we are driving at 35 miles per hour. So what does that mean? It means that in 1 hour, we will drive what? 35 miles. Okay? Notice that I call this unpacking. I took the MPH and I unpacked it to this. I unpacked, not impact, unpacked. So I hope that makes sense. In fact, I want to do one more thing. Instead of kind of taking this sort of slanty 35 miles per 1 hour, I'm going to go ahead and flatten it out. This is what I mean. I'm going to go ahead and say that that car goes 35 miles in 1 hour. Does that work for everybody? I think so. So we've got some examples coming up where you're supposed to come up with the speed. Now, not just any speed, but actually we're going to talk in this course anyway about just the general average speed. Kind of the opposite of average would be what we call the instantaneous speed, and that takes a little more, actually that's kind of taking something more akin to calculus than what we're doing. So to calculate the average speed of anything, all you got to do, and like this slide says, it's going to start at location A, we've been talking about, and end at location B, not too bad. Okay, we need to take this distance, and we need to divide that distance by the time it took to do that, to relocate it. And that will give you the average speed over that segment. So let's look at an example here. Here's an example from your textbook, and it's got a few things. If you start to kind of look at it, basically these time intervals are what? 1 second apart. Okay, we're going from time is equal to 1 second to time is equal to 2 seconds to overall time is equal to 3 seconds. So what? There's a 1 second in each one of those intervals. That probably makes sense. And notice for each of those intervals how far, what's the distance? Okay, it's going 20 meters for each second. I can't quite picture that. I think that's pretty fast. So actually one way to kind of quick and do it, notice our question is to say what is the average speed in meters per second. So dang, I'm getting this. So average speed is equal to what? 20 meters per 1 second. Okay, that's pretty cool. Now if we wanted to go ahead and calculate the full 4 seconds worth, so if we call this location A and this location B, okay, the distance it went from the distance it went from location A to location B would be what? I got, let's see, distance, I'm thinking what, 4 times 20 meters? 4 times 20 meters. Okay, so the total distance is 80 meters. The time, well, there were 4 segments and they were each 1.0 second long, so I'm getting 4.0 seconds. And you might be, well, what's the difference between 4 seconds and 4.0 seconds? Well, actually, it makes a difference in our calculation sometimes. And then we do a lot of, a fair bit in physics with formulas. So the formula actually for average speed is simply a ratio or division of distance divided by time. I know I'm making this probably more complicated than it needs to be. So then we can kind of finish off this problem. Average speed is equal to, what, 80 meters divided by 4.0 seconds. Okay, and put that in your calculator and you're going to get a value of 20. And we kind of talked a little bit about rounding. Your calculator is going to say 20. And let's see, how do I say this? There is one digit here, and there's actually two digits down here, which I don't know if I emphasized that when I talked about rounding, but so we can only round according to one digit. So, yep, so 20 is the right number, and one of the things when you write down your answer to science problems, don't forget the units. So our units are meters per second. Okay. So I thought about when you work physical science problems, whether they're physics or chemistry or I guess astronomy even, here's some hints. Draw pictures. It helps. It buys you time, and a picture's worth 1,000 words. It's optional. Hopefully you draw a better car than I do. Feel free to just kind of throw out there related equations that you think may or may not help you. And if your problem is written in like a paragraph form, what I like to do is kind of pull out the numbers and kind of put them on my doodle area. And oftentimes I will unpack, and we'll be talking more about unpack, but just simply take units and make sure I write them clearly with a numerator and a denominator. I would always make sure that you keep your units. So if it's length, it's probably going to be, well, if it's length, for instance, it might be meters. If it's mass, it might be kilograms or grams. Make sure you have your units throughout the problem. And that's not optional. Units are not optional. Also, what's not optional is you need to show all of your work. You need to, if you put anything in your calculator, it needs to also appear on your paper. That's just a good habit to get into, and that's one of my requirements. And it helps you work the problem oftentimes. So this is an assignment from your textbook, and I've gone ahead and given you screenshots. I don't know if you can actually see these very well. But one of the things I like about this textbook is it kind of does the problems anyway in pairs. So you are only supposed to do problems 8 and 10. So here's problem 8 and here's problem 10 in chapter 2. The cool thing is 8 has a kind of similar problem for which the answer is given. And 10 has a similar problem or analogous problem for which the answer is given. So a thought then would be that you can, it just might help you. So